there, Gaurav is there. So I am giving this lecture on an outline basis about the night sky and the wonders of the night sky. One thing one should remember, that just by seeing through a small telescope, sometimes we can catch the wonders, but we can't see their details. So I am using here the pictures from all the celebrated telescopes, including space telescopes here, to give a glimpse of the night sky and universe as a whole. I hope I can complete this within 1 hour. Okay, I'm starting. Is it visible clearly?
It is visible, sir.
Okay, thank you. First, I'm going to start with the picture of today's night sky. This is the picture of today's night sky. Not night sky, but the evening sky around 5:30 p.m. When you can see the sun here. This is the sun here, which is about to set. And Venus and Mercury are very near to the sun. So actually, during this period of time, it has become difficult to see these planets because they are within the sun's glare. Venus is brighter, but Mercury is too faint. And it is well within the glare of the sun, so it is very difficult to see. I have seen Mercury only twice, one from Aries Observatory, Nainital, and other from another place. And if you go along the ecliptic, there is an imaginary line called ecliptic, and you will find Jupiter almost at the zenith and Mars following. And these are the constellations, you all know. These are the mythological figures. These figures bear resemblance with the living or non-living objects, and these are called the constellations. And all these constellations that lie within this ecliptic are called zodiac signs. So here is Jupiter overhead and Mars around 5:30 a.m. Now it is around 7:15 or so. Jupiter you will find move forward towards the west, and Mars is now almost near the zenith. So this is the sky condition, and there are lots of bright stars here and there. You can see these are the two bright stars of Gemini, Castor and Pollux. And here is Jupiter is in Taurus, so there is an Aldebaran, and lots of like this. Sirius is there also. So this is Orion, a very fantastic constellation, followed by Sirius, the brightest star we see in the naked eye. It is the naked eye visible brightest star, but it is not actually the brightest one in the sky. However, while I am now going into details within this deep sky, first let's start from the home. This is the picture of our solar system, and we all know the picture. At the center of the picture lies the head of the family, the sun, the only star in the solar system, being encircled by the 8 classical planets. From inwards to outwards, these are Mercury, Venus, Earth, Mars, the largest one, Jupiter, Saturn, Uranus, Neptune. And we all know that Pluto, along with some other bodies, are now regarded as the dwarf planets. But in our book, what is important that in our books, we always find this picture like this. So we have an idea. In childhood, I have also that idea that the solar system ends at Pluto, but this is not true. In fact, solar system lies well beyond the Pluto. See, if you can see the solar system from a distant place in the universe, so a distant place from a Milky Way galaxy, you will see this much like a picture. This is the sun, and you can assume here is Pluto. And there is a very, very wide area beyond the Pluto. These are called the trans-Neptunian area. The place around the Pluto and beyond the Pluto is called the Kuiper belt, Edgeworth Kuiper belt, and followed by the Kuiper belt is an Ophioid cloud. These are the whitish dense-like regions. These are actually vacant spaces and inhabited by the cometary nuclei. So if we board on some mythological spacecraft, then we can go outside the solar system. We will see that all the sun and all the planets are going inside, and we are coming to the Kuiper belt, and following Kuiper belt, Oort cloud, and outside Oort cloud lies the interstellar space. In between the Kuiper belt, around the Kuiper belt region, there is a region, imaginary region, that scientists call the heliopause. Helio means sun and pause means to stop. This heliopause is actually the boundary of the solar system, and now the two spacecrafts, Voyager 1 and 2, are crossing these heliopause limits, and they are literally going outside the solar system. Beyond the heliopause lies the Kuiper Oort cloud, and outside the Oort cloud is vacant, absolute, is not absolute vacant, but vacant, which is called the interstellar space, and these are the dotted with stars. These are the stars in the interstellar space that we see in the night sky. When you look at the overhead, we see the sky. These are actually the skies of the stars of the interstellar space. But one thing should remember, that interstellar space, though it is a very much vacuum and void by our standard, but it is not actually matter-less. It is not actually matter-less, and it is not actually empty as such. In strict sense, it is not actually empty. However, if we go back to our sky watching, we should limit ourselves to sky watching. And there is a very common question when a child looks up at the sky, since his childhood. Sometimes we may ask the questions: how many stars are there in the universe? There is a undaunting questions: how many stars are there in the universe? This is the picture taken by famous astrophotographer Akira Fuji from Japan. Akira Fuji is a very famous astrophotographer, and you can see his websites and photos all over the internet. And what this picture tells us, each and every dot in this picture, see, each and every dot shown in the picture is actually star. So this area is actually inundated with stars. And how many stars? Computer simulation shows us that this is an area of only 2 degrees of the sky, and this 2 degree area of the sky is dotted with almost 2 crores of stars. So we can imagine how vast is our universe. Scientists use a very wondrous term, very colloquial term, to describe how many stars are there in the universe. Most of us, we have in the seasides, in the lots of seasides, and you can see in the seasides there are lots of sand particles. Scientists are of opinion that there are more stars in the universe than all the sand particles of all the sea beaches combined together. So you can imagine how vast is our universe. Now, coming to naked eye, this is again a picture from Akira Fuji. These are actually true pictures. All these are true pictures. And these are the bright stars. If you notice at the sky, you will see these are the bright stars, and these dot-like stars are the faint stars. These are called the faint stars. Since ancient times, since mythological times, suppose you can go back some 1,000 years. So in 1,000 years, at that time, people used to join the stars with their imagination to create the numerous figures on the night sky. If you go back, suppose on imagination, go back to some 1,000 years ago, on that night sky at that time was completely different. Why? Because if you go back few hundred years back, there is no pollution, no vehicular pollution, no light pollution, nothing. When the sun sets, there is absolute darkness without the moon. There is absolute darkness, absolute pollution-free sky. So at that time, some person at that time was in, suppose I am some people from 1,000 years back, I can see these stars, this night sky flooded with stars. This scenario is not actually possible nowadays, especially from this any landmass. Especially from this landmass. So these are the pictures that ancient peoples experienced, and they got captured by the imagination, the beautiful, the oneness of the night sky. And they used to join these bright stars out of their figment of imagination and created the mythological figures. So actually in schools and colleges, I sometimes request students to join the stars and to form the figures. Some students replied me, sir, it looks like a kite if you join these 4 stars. some says it looks like a kite, some says it looks like a paratha, and some says it looks like a map of India. Now I'm joining this figure on my laptop, and you see what ancient Greek people, well, ancient Greeks thought about it. Now I am joining it. See, they imagine this as a swan flying across the sky. This is the eye or the head of the swan. These are the two wings, and this is the tail. These mythological figures are called constellations. This is the constellation of Cygnus, and all these mythological figures bear very beautiful stories of night sky along with them. Out of human imagination, there are the 88 constellations in the night sky. If you consider the full sky for both northern and southern hemisphere, you will get 88 constellations carved out of night stars, out of the imaginations of the ancient peoples. Somewhere you can see a figure of a girl, constellation Virgo, or the zodiac sign of Virgo in the sky. Somewhere you can find a big lion, roaring lion, the constellation of Leo, and somewhere you can find a big snake winding its way across the starry heavens. This is the constellation Hydra. So these are the lots of constellations, sir, and out of these constellations, those which only fall across the ecliptic are called the zodiacal constellations or zodiac signs or sun signs. But as far astronomy is concerned, as far science is concerned, sometimes we attach our superstitions, we attach our futuristic plans with the zodiacal signs, but as per science, as per astronomy, there is nothing like that. These are all superstitions. Now coming to this one, there's a great bear called Ursa Major. The tail of the Ursa Major, if you fix your notice on this tail part only, the tail of the Ursa Major consists of the 7 beautifully aligned asterism or stars called the Big Dipper or Saptarshi Mandal in Sanskrit. Named after 7 great saints of ancient India, this Saptarshi Mandal plays a very important role in guiding of the night sky. And it is one of the part of my class in navigational astronomy to find out the north star, to find out the north using this Saptarshi Mandal and Cassiopeia. These are the 7 stars of Big Dipper. And if you join, these are all true pictures. Okay, these are all real pictures. And I have joined these lines, draw these lines to give this prominent shape of the constellation. During summertime, actually summer is coming, you can find this Big Dipper over it. In June and July at 6 p.m. or 7 p.m. in the evening, you can see it just run over it. If you join these 2 stars of the first 2 stars, 2 to 1, second to 1 first, and extend this line almost 5 times towards north, you will see a very faint star in the northern sky. This is the pole star. Actually, I have seen people have a wrong idea that pole star is a very bright star, but that is not. Pole star is not a bright star. It is a faint star. It is a faint star, but also it is a very astronomical important star, not only for navigation, but also for scientific reasons. It is a Cepheid variable star, and this pole star acts as a guide in the northern sky. In the southern sky, actually, there is no equivalent of pole star, and that's why before the invention of compass by Magellan, the people actually got lost their way in the oceans, because without the pole star, equivalent of pole star in the southern sky, they at night, they actually got clueless about the directions, and the ship roamed mercilessly on the vast ocean. But in the northern hemisphere, this is not the case, because pole star is there. So if we can locate this pole star by joining the 2 stars, Merak and Dhruve, from this Saptarshi Mandal, and extending this line 5 times towards the north, you will find a very faint star called pole star. And during the winter season, the Saptarshi Mandal is not visible from our Indian or these mid-latitude countries, and there you can see Cassiopeia. This beautiful blue-shaped Cassiopeia is mythologically the queen of Ethiopia. She was the queen of Ethiopia, and if you bisect this angle and extend this line, you will find the pole star very much like the way of the Saptarshi Mandal. But if you move, I have this privilege to see these two constellations side by side or near the North Poles. I have went inside the Arctic circle, or within the Arctic circle, almost 70° north, and there I find the pole star and Saptarshi Mandal on one side and Cassiopeia on the other side, and the whole sky is rotating around this pole star. It's a very beautiful, but from this mid-latitude countries, this is a very difficult to imagine. You can see some photos. I have not come here with these photos because I know this is a shortened lecture. One second. One second, please excuse me. Please excuse me. I have one. Hello. হ্যাঁ বলো 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 ওকে 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 কালকে আমি সকালে ফোন করবো, এখন একটু বিজি আছি। Sorry. This, but from mid-latitude countries, you can see these two stars do constellation side by side. It is not possible from India. But in long exposure photographs, you can see Anupam is here also. Anupam is one of our star astrophotographer. You can see these pictures of the stars revolving around the pole star. These are called the circumpolar stars. And you can see there are lots of pictures by Anupam, other astrophotographers, even from Ajay Talwar. There are fantastic pictures of the circumpolar stars around the pole stars taken from various length and breadth across the countries. However, coming back to our lecture, this is Cassiopeia, the mythological queen of Ethiopia, and actually the mother of Andromeda. This Cassiopeia acts as our guiding constellation to the pole star during the winter times. But if you look at the night sky, you will find that all stars are not of the same color. There are various stars of various colors. Some are reddish, some are whitish, some are blue, some are orange. Why? To understand the basic physics, why the stars appear of different colors, we have to just look inside our kitchen. In our house, in our kitchen, we can see the flames, we can see the fires, and if you notice carefully, we actually encounter fires of different colors. Not all fires, all are fires, but not all fires are of same color. Just imagine, these are for the school students, just imagine this picture. This is a gas oven burning, and you will see the color of the flame coming is beautiful, brilliant blue. Now, if I wet my hands and shake my hands over this flame, drops of water will fall on this flame. And as soon as the water droplets fall on this flame, you will see the flames flickering and color changes from blue to yellow. Why? Because as soon as the water droplets fall on the flames, the temperature momentarily drops, and as at the moment the temperature drops, color changes from the flame from blue to orange. At the very next moment, the water droplet will evaporate and the again blue color will come out. So this means the fire which is more hot, or rather hotter, are bluer in color, and which are colder in sense are actually yellowish or orange in color. This is actually the spectrum of our VIBGYOR, the electron spectrum, color spectrum of the visible electromagnetic spectrum, part of the electromagnetic spectrum, from violet to red. This VIBGYOR is actually the decreasing of the temperature, decreasing of the color temperature. Hotter the fire, hotter the color, bluer is the region. And if you move across this from hotter to colder regions, you will see color changes from yellow to orange to red. So is the case with the stars. The stars with the surface temperature around 50,000 degrees centigrade are actually violet in color. One is in Vela Pupiz. example is Velopipis, which is actually violet in color. And if you go across the spectrum, you will encounter the stars with some 25,000 surface temperature, and you will see blue and white stars. Actually, Govt is here. Govt is one of the experts of classical B stars. These are actually fall within the blue-white regions of the spectrum. Our sun has a surface temperature of around 5,500 degrees centigrade, and it is a yellow star. The photosphere of the sun is yellow in color, almost yellow in color, and emits its major portion of the visible light in yellow. And if you can encounter also colder stars here, these are the orange and red region. There are lots of reddish and orange star just over it at this moment. One very fantastic, beautiful star is Betelgeuse of the Orion. It is just now overhead at this point of time. It is 7:30 p.m. It is around overhead, almost overhead. The Betelgeuse, it is a red supergiant star on the verge of its supernova explosion. There is also Aldebaran near Jupiter. It is also some overhead past towards west. So you can also, this is also an orange star with the surface temperature around 3,000 degrees centigrade, more or less like 3,000 degrees centigrade. These are actually the dime stars or the red giant stars. So coming back to sun is actually the yellow star. It is a yellow star with the photospheric surface temperature of around 5,500 to 6,000 degrees centigrade. And when we come to sun, let's have a look on the sun. This is the picture of a sun taken by our member Anupam Nashkar on 6th June 2012 from a camp organized in Kolkata during Venus transit. And this black dot is Venus. On that day, we have witnessed the Venus transiting across the solar disk, and lots of camps for observing Venus are held all along India and many parts of the world from where it is visible. This is actually the disk of the sun. This picture is taken with a filter attached at the objective of the telescope, so the color you show is actually dimmed, and this reddish tinge or blackish parts are actually the clouds. There are few scattered clouds here and there. But if you look carefully, there are lots of black spots here and there, and these are nothing but the sunspots. This visible solar disk, this is the visible solar disk. This is called photosphere. It is actually the third layer of the sun. The first layer of the sun is corona, followed by chromosphere, followed by photosphere. Photosphere is actually the visible disk of the sun, the disk of the reddish disk that we see during the rising and the setting sun. This is photosphere, and it has a temperature of around 5,500 to 6,000 degrees centigrade. But these are the sunspots. These are actually the regions with the colder temperatures. And these are the sunspots. These spots are not actually black. Due to their low temperature, these spots emit lesser light. These spots emit less light, and they look black against the overwhelming brilliance of the photosphere. Through a small telescope or amateur telescope, you may look sunspots like this, but through larger solar optical telescopes, this sunspot, look at this sunspot. This sunspot is actually, see, this is the sunspot almost 3 times as large as the Earth. This sunspot can engulf the 3 Earths, and these are actually the surface of the photosphere. What we see here, the surface is a blank yellow disk is actually filled with the bubble-like structures called granulations. These are called granulations, and these are the bubbles of actually plasma. These are the bubbles of plasma. This is actually the picture of the surface of the sun. Now I will show you one very famous time-lapse video from one solar observatory, SDO, Solar Dynamics Observatory by NASA. There are lots of solar observatories now at the sky. There's Hinode from Japan, Stereo A, Stereo B. This is this one SDO, and also we are proud to announce that we have our own solar observatory at L1 point, Aditya L1 probe. Aditya L1 probe is launched last year. So it is our own solar observatory, and it is now observing the sun along with all its instruments on board. So I am now showing you a time-lapse video of the sun of this SDO or the Solar Dynamics Observatory. See. This is a time-lapse video, and you will see the sun in true colors taken through different filters and different cameras. So sun, as such, the sun may appear in different colors and different shapes and forms. Just enjoy. This is actually Venus, a video taken during Venus transit. This is the photosphere of the sun. Temperature of around 5,500 to 6,000 degrees centigrade. And these are the magnetic lines of forces. Actually, what happens, strong magnetic fields prohibits the upward upliftment of heat from interior. And when these magnetic lines of force snapped, a violent amount of magnetic energy spewed out into space in the form of the solar flare. These are the magnificent solar flares, few lakh kilometers tall. This solar flare is actually few lakh kilometers tall. They rise abruptly over the solar surface and die down on the solar surface. You can see the magnetic lines of force are forming in this live time-lapse video by the Solar Dynamics Observatory. This amount of stretch is generated within these lines of force, and sometimes they snap. And as soon as they snap, huge amount of magnetic energy is spewed into the space in the form of these magnetic loops and ribbons and solar flares. This is the photosphere, the third layer of the sun, and from outside inward, this just above the photosphere, there's a layer called chromosphere, or the colorful layer. Chroma means color. This is actually in optical. This picture is in optical. Chromosphere around 10,000 degrees centigrade, and followed and after chromosphere towards the outer region, there is the crowning glory of the sun, the corona. Corona is some million degrees centigrade hot, 10 lakh to 20 lakh degrees centigrade hot, but it is very faint. Its heat budget is very low, and hence it is not visible to naked eye due to the brilliance of the photosphere. Only during the total solar eclipse we can see the crowning glory of the sun. And from outside to inside, we can't see inside well with our telescopes. Inside, just below the photosphere, there is convective zone followed by radiative zone, and at the center there is the core of the sun where actually the solar engine is running. The thermonuclear engine is running. The temperature is around 1.5 crore degrees centigrade. This is sun in ultraviolet. This is in infrared. If you went through the different websites, you can see these are all in websites, all in NASA and European Space Agency, and also in ISRO's websites. For the Aditya L1 mission, you can see several other live videos of the sun, our sun in action. By studying sun, scientists are trying to get a glimpse of the different stars in the skies. All the stars that we study are actually far, far away from us, which makes it difficult to study. But sun poses just the opposite problem. It is too near to us. So it is also easier to study, and at the same time it is difficult to study because it is very near to us. You can't actually look at the sun with your naked eye or through any unaided telescope or something. If you try to look at the sun through your binocular, to a telescope with a proper filter, you will get instant blindness. And there are lots of also other hazards. I'm not coming into that. But sun is the only lone star in the solar system, and that is our boon, because sun has no companion. But most of the stars in the sky are not companionless. Most of the stars are in clusters, are either binary stars or triple stars, or in clusters, as you see in this pictures. These are the three pictures of the open star clusters. Open star clusters are loose association of mostly young stars that share common origin in the molecular cloud. And this is the open star cluster called Pleiades, which is actually visible in the naked eye just now. If you go outside just now and look over it at the constellation of Taurus, you will find the 5 or 6 or 7 stars are clubbed together to a very small region. It looks like a speck, white speck in the sky. This is called Pleiades, clustered around 375 light years away. These are all dotted with young stars. Why are you saying young? Because every star has a life cycle. See this picture by Hubble Space Telescope. It is an open star cluster of 136 in the Large Magellanic Cloud. See the brilliant bursts of the young stars in Large Magellanic Cloud. The name young, the term young implies the stars has a life cycle like us. Every star, like a human being, has its birth, childhood, puberty, adulthood, senescence, and death, just like us. So stars are, you can say, only this time scale is different. We live on Earth for 90, 100 years. Star live in the universe for crores of years. Only the time scale is different, but every star has to pass through more or less through these cycles. So, like the young stars, they are senior citizens of the night sky. These are the old stars. They are literally the senior citizens of the night sky. And just now on the screen, you are seeing Omega Centauri, a brilliant globular cluster 17,000 light years away by Hubble Space Telescope. See, thousands of stars are packed in a small region of space. These are globular clusters, and this is a gravitationally bound system. These stars have estimated age of around 1200 crore years. And since that time, since that huge span of time, 1200 crore years, they didn't left each other. This is a gravitationally bound system, and lots of these globular clusters are visible in through a small telescope. Through small telescope, we will see just like a fungus-like white specks, and with large telescopes, we will see its details. This is the picture, see, by HST. So obviously, it has far more details which you can't see in any amateur telescopes. Without this graph, there is actually all the discussions about the stars, all the discussions about night sky and astrophysics led to us to this beautiful graph. It is one of the most famous graph in the history of science, called Hertzsprung-Russell diagram. As I said, every star has its birth, childhood, adulthood, senescence, and death. And all these life cycles are put together in this graph called Hertzsprung-Russell diagram. It is a graph that generated more than 7,500 PhDs throughout the world. So this is the most famous graph I can assume in the history of science. you all know this. I am not, because time is not also. I have another program of Sunita Williams in our TV, so I have to just join them at 5 p.m. This along this x-axis, there is actually the color temperature of the stars, followed from, this is not 00. Actually, the in graph with this is 00 point, but here not it is. It is actually very O stars, very high temperature regions. For this temperature decreases that way, and along the y-axis, this is the luminosity or the actual brightness of the star, not the brightness that we see. It is the actual brightness or actual light output by the star, and it increases along this x-axis. One is taken as sun. This one is taken as sun. Our sun is here. See here. One is taken as here, and here it is G. And along this line is called the main sequence. Along this line are all the stars in their adulthood. What does adulthood means? Adulthood means star that is in active hydrogen burning stage. All the stars are in hydrogen burning stage, and when the stars die, they move outside this main sequence, and they inhabit these regions, different other regions of the graph. Time is not here to discuss the details, but we can dedicate a full lecture or more than full 2 or 3 lectures on this diagram alone. This is the diagram. It is the holy grail of astrophysics, this Hertzsprung-Russell diagram. So I am now coming to birth of a star, but this is a popular lecture, so I have to limit my talk within the popular sphere of this thing. So coming to birth of a star, birth of a star is actually a very difficult process, but again I am limiting myself to the popular lecture. The stars show their birth towards the dense molecular clouds in interstellar spaces. Just like us, like human beings, like mammals, they owe their birth inside the mother wombs. These giant molecular clouds are the mother wombs of the stars. The one in the picture is Cone Nebula, 2000 light years away in Monoceros. Image HST means Hubble Space Telescope. Within this inky jet black column, new stars are born out of gas, pollution, gas and dust. And you can see this top of this nebula, it is shining with the light of the new young stars, of the newborn stars inside the cocoon. We can't see these new young stars because these are embedded within the cocoon of gas and dust. Some after their birth, these stars, these polar jets make the gas on the top of the polar jets to shine. These are called the Herbig-Haro objects, and we can see these Herbig-Haro objects after for a limited period of time. Obviously, limited period doesn't mean 1 or 2 years. Limited period means a long year as compared to our human lifespan. But after this, and you can see literally the new young star with these polar jets actually radiate away. These polar jets actually cleans the area around the newborn stars, and then we can see the young stars. At the moment of birth, it is actually very difficult to see the stars because it is deeply embedded in the cocoon of gas and dust. These are the other pictures. See the beautiful pictures by Rector and Gulpa in the 6,500 light years away in Serpent. These are called the columns of creation. These are called the columns of creation, Eagle Nebula. And as per the photography, these reddish tinge, reddish colors of the gas is from the re-radiation of the different wavelengths, and these blue colors are called the reflection nebula. These reddish parts are called the emission nebula, and the blue color is called the reflection nebula. This part is actually reflecting the starlight. See, this is one of the stellar rooms very near to our house. It is an Orion Nebula. If you see Orion Nebula, you can see the 3 stars that make up the west of the belt of Orion. From that belt, you will find, it is visible in naked eye, you will find the sword case. Case of the sword is hanging. The middle star of the case of the sword is not a star, it is Orion Nebula. See this beautiful one, and the stars are forming here. See this region, it looks like an overexposed photography because the new young stars are there. Even through a small telescope, some 6-inch telescope or 8-inch, you can see these 4 young stars called the trapezium. And out of this trapezium, one star Theta Orionis C is responsible for the brightness of this beautiful nebula. It is one of the closest star forming region to our solar system. Now, coming again to this Orion Nebula, there is another beautiful nebula, but it is not within the range of naked eye. It is called the Horsehead Nebula. This dark nebula is silhouetted against the glowing background of hydrogen, and Wide Field and Planetary Camera 2 of the Hubble Space Telescope brings out the life of this head of the Horsehead Nebula. See it like almost like the hood of a cobra. Hood of a cobra. That is the stars are forming out there. Now, as I told, the stars after adulthood, after their active hydrogen burning phase is over, they encounter old age. During old age, the stars have their different way to behave according to their birth mass. The stars are categorized according to the birth mass. The stars with the mass 1 or 2 of the solar mass are called low mass stars. 2 to 8 are called the medium mass stars, and beyond 8 solar mass are called the high mass stars. For all the low solar mass stars like our sun, end will be in that way. After the hydrogen burning phase is over, stars will enlarge in size, their colors become red, and they expand to a huge ball of fire called the red giant. This is a very long video. I am not going into details. I am showing you only the important parts. See, after these things happen, the stars from main sequence went up there to the red giant. It becomes large in size. For the sun, for our sun, it is calculated that it will engulf Mercury and Venus and come towards the Earth. After this, the outer envelope of the sun goes away to form the planetary nebula, and the core of the sun becomes exposed to form a ultra wide dense object called the white dwarf star. This is the white dwarf star. Our sun will become white dwarf after some 500 or 600 crores of years. We can't live that long to see our stars, to see our sun to die, but we can see the other stars dying in different corners of the sky through our beautiful telescopes. These are the 6 images of a dying sun-like stars from the Hubble Space Telescope. This is Spirograph Nebula, this is Cat's Eye Nebula, this is Blinking Nebula, 8 Burst Nebula, Clownface Nebula, 3000 light years away in Gemini, and this is the Glowing Eye Nebula. Our sun will end up its life in one of these meritic stages in the beautiful display of colors after 500 or 600 crore years away. See this very beautiful picture by the European Southern Observatory. It is called the Cosmic Engagement Ring, much like the diamond ring that we see during the total solar eclipse. This is actually the star. This star that I'm pointing out, this star is actually the white dwarf star or the progenitor star, and this is its planetary nebula. When we are taking this picture or aligning the telescope, this is an unrelated foreground star. This is an unrelated foreground star. It comes on its way in such a way that it looks like a beautiful diamond ring. We jokingly called it the cosmic engagement ring. But this is the true for the young low mass stars. But for high mass stars, the stars that have a birth mass more than 8 solar mass, they have a different death. They have a violent death. Just before their death, the high mass star, if you cut a high mass star, you will see the high mass stars from the layers of these elements, like the layers of onion: helium, carbon, oxygen, neon, magnesium, and that inside one is the black one is the iron. When iron develops at the core of high mass star, the end is near, the expansion, the heat output stops, and suddenly the star collapses. The thing is not that easy, but I am just telling you in a short line. You can arrange different lectures on this particular topic also, the process of the supernova. When the iron developed at the core of high mass stars, heat output stops, and suddenly a star's life comes to a stall mark. The star's life is actual and hydrostatic equilibrium balance between the inward crush of gravity and outward expansive force of the heat. As soon as the heat stops, heat generation stops, gravity trumps and collapses this whole stars on that ball of iron to form the massive explosion called supernova. See this animation. This is the formation of Crab Nebula. This is the formation, animated formation of Crab Nebula. See, this is a Veil Nebula, the remnants of a supernova that shattered itself some 50,000 light years away. And through this supernova and other cosmic processes, all the elements known to us are formed, except hydrogen that formed during the Big Bang. And all other elements, starting from lithium to these are few there. These are called the artificial elements, as these are transmuted or created by humans. But all other elements are cooked up either in the interior of stars or by some other cosmic phenomenon. Our whole periodic table is actually nothing but the process of the stellar nucleosynthesis. And when the stardust came to Earth under what I can say, biological supporting environment, that materials, that elements conglomerates itself into a new form with a special manifestation of power that is called life. This is the DNA, the ultimate molecule of life. And if you break this DNA, you will find nothing but nitrogen, you will find hydrogen, you will find phosphorus, and these are all non-living elements. So you can say this, our life is actually a conglomeration of non-living elements. Actually, these are non-living elements. So life is nothing but a special manifestation of non-living elements in special forms, and all stardust. This is the picture of a virus, picture of a plant cell and animal cell, and all are cooked up from the stardust. So when we drink some health drinks, say Horlicks, Complan, Bournvita, Boost, or anything, you can safely say, I am drinking a cosmic soup. These are the level taken from the Horlicks. See, there is iron, zinc, iodine, calcium. These are not at all created by the Horlicks company. These are all created at the million degrees centigrade at the interior of the stars. And these, they present us in the form of bottles. So when you drink these health drinks, you can safely say, I am drinking cosmic soup or the star soup. And everybody, every child, every living creature on this earth is actually a star child, because our body is made up of star dust. Now we are now nearing to the end of the lecture. Now we are entering the deep space beyond our Milky Way galaxy. This is Andromeda galaxy, 22 lakh light years. It is a neighboring galaxy of the Milky Way, and the farthest point a naked eye can see. It is the farthest point in space where a naked eye can see. Going further deep is southern Pinwheel galaxy in Hydra, 1.4 crore light years. And one thing one must imagine, that as we is seeing deep and deeper into space, we are moving further and further away back in time. It is like a time travel. 2 crore light years away, Whirlpool galaxy. I don't know, I actually forget the name of the photographer who pictured this beautiful galaxy in Canis Venatici. There are lots of pictures of this Whirlpool galaxy from European Southern Observatory or HST or something like that. But this picture is actually fantastic. This picture is actually fantastic. The Whirlpool galaxy in Canis Venatici. If I go further deeper, 30 crore light years away, I am telling you again that for looking deep and deeper into space is equivalent to moving back and back in time. 30 crore light years away, 2 interacting galaxies called galactic cannibalism in Draco. 2 galaxies are the merging galaxies. 2 galaxies will merge, and eventually a large elliptical galaxy will form. If we move further inside, 200 crore light years away, it is the Hubble Deep Field, Hubble 1689. There are lots of pictures in the net. You can see as the Hubble Deep Field and Hubble Ultra Deep Field, where every dot except these ones, 1, 2, 3, 4, except this 5, six. Except these 6 dots with the star-like specks, these are the stars. And every dot is a galaxy. Every dot is a galaxy. Now with the James Webb Space Telescope, we can see even further. And this is the galaxy that formed almost 30 crore years after Big Bang. Till now, it is the farthest celestial object known to man. It is the farthest object, it is the most oldest object that is known to man from the James Webb Space Telescope Advanced Deep Extragalactic Survey. You can see this image within JWST's homepage on the net. That means as we move from this earth, see this beautiful picture, as we move from this earth, these are given in light time, 2 light seconds, we encounter moon. 4 minutes, 8 light minutes, we encounter sun. And as we move further and further, we are going back in time. And theoretically possible, not practically. I am telling you again, not practically, but theoretically, if you move 1300 crore light years, 1300 crore years back, or 1300 crore light years, you will encounter the moment of creation, the Big Bang. But this is not possible practically. Well, now I'm just at the very end of my lecture. These are the very interesting 2 pictures. These are called the large-scale structure of the universe. I'm not going into details how scientists created the large-scale structure of the universe from the WM map or something like that, from the Kobe satellite pictures. But these dots, well, you see these dots, each and every dot forms a galactic supercluster. Within each dot, there lies thousands of galactic clusters. Within each galactic cluster lies thousands of galaxies. And within each galaxy is billions and billions of stars. And when these pictures got published, one thing is very interesting. These 2 pictures got some uncanny resemblance with our old Indian mythological tradition. With our old Indian mythological tradition, these 2 pictures of the large-scale structure of the universe oddly resembles the dancing Nataraj figure. You will don't go beyond that, because there is this just by coincidence. There is nothing else, but it is a beautiful coincidence that the large-scale structure of the universe resembles the dancing figure of the Nataraj of the ancient Indian mythology. Now, this is a very last slide, and this is the beginning of the universe, Big Bang followed by inflation, and this is the present age. Now, the most interesting part is that if we can add up all the things that we discovered, all the things that we see, that billions of galaxies, that large-scale structure, that huge amount of unfathomable amount of energy, if you join these 2, you will only get 5%. And rest 95% is the dark matter and dark energy. Why it is dark? It is not dark because it is dark, because it is dark in our intelligence. We don't know now exactly what is the nature of this matter and energy. But if you add up this 27 and 68, almost, it is almost, not exact figure, 27 and 68, you will find 95. This 95 part of the universe is composed of dark matter and dark energy, the exact nature of which is unknown to man. Lots of scientists are working on this, lots of theories, hypotheses are coming out, but nobody actually get a clear description of what is dark matter and dark energy. So for the young students, for the young aspirants, if you wish to dedicate your future in astrophysics and cosmology, researching on dark matter and then dark energy, and if you can bring out some light on it, international exposure, international pride, and even Nobel Prize is waiting for you. So there is a very interesting term in our line that your future is bright in the dark universe. For any aspiring scientist, astrophysicist, cosmologist working on dark matter and dark energy, if you can throw any light on the real nature of dark matter and dark energy, you are sure to get international recognition and Nobel Prize. That much for today. Thank you very much for this patient listening. I am ending this with thank you to everybody. Thank you.
Thank you very much, Kaustubh Chaudhuri ji. for presenting such a luminous lecture talk on the cosmos, colorful cosmos from Polaris to deep sky. And as you said, that the colorful talk of the dark cosmos you have presented, and we have enjoyed it. On behalf of NASNI, I thank you very much for sparing time for this talk. I request all the members, if you want to ask some question, you can ask your query from Mr. Kaustuv. Any question? There is no question in the chat box.
Sir, I have another program on TV.
Okay.
So I have
So
to.
you want to leave? Okay, okay.
On Sunita Williams.
So thank you very much for.
Excuse me.
Thank you so much,
everybody.
I request Professor Ahluwalia sir to give the remarks. Dr. Kulkarni, you want to say?
Yeah, I just have a word of appreciation. It's a great introduction. Yeah.
Hello,
it's
sir.
a great introduction he has done. He combined physics and chemistry and biology, and some amount of mathematics would have been nice here, and concept of space and time. It is a very nicely presented lecture.
Thank you, sir. Madam Reshma, you want to say?
Yeah. Yes, I really want to thank sir for this. I must say that this is one of the most wonderful talk that I've heard on wonders of the universe.
You're right.
And of course, mysteries of the universe. I think sir has left, but like it's for our NASNI group to really think now. If 20 years ago, if you were to look at the sky, few initial slides that sir has shown, we were able to see, but today we can't. Maybe one of the objectives I thought we could carry forward to NASNI group if we have that kind of sky back and do this kind of wonderful observations without, like many of the slides which sir showed were from space telescopes, but the initial slide naked eye or a small telescope, which is not possible at right now, and that's all because of the pollution that we have. So I will only say that sir has really brightened up my mind just to think on this direction, that we really need to do something so that universe very much.
You're right. Thank you, madam. Madam Dekra,
yes,
please
sir.
go ahead.
I would also like to. I was really enjoying his talk. He has, as Kulkarni sir said, he has spoken from chemistry, physics, and
biology.
All biology and everything together in such a nice way, with beautiful diagrams, and it was easy to understand. And when a star dies, what lovely pictures he shown us. I was really overwhelmed by those pictures. And the thing that he said, from the Arctic Circle, they have taken photographs. I was just imagining, let me tell you that if we go from the NASNI group, we can make an expedition to that little point and really have some observations from there. Those who volunteer to go, I think I'll be the first one to volunteer to go. I would love to go to that Arctic Circle point and really see what is really happening in the sky. As he told us, they have taken pictures from that point. So I was really wondering that it must be so wonderful. And it is very interesting. And how he said the dark matter, that means actually, when I was teaching nuclear physics in college, that how the origin of the universe, the Big Bang theory and all these things, actually we really don't know what happened, how it really originated. And today he told us that dark matter, dark energy consists of 95%, and only 5% only we know actually. So that is also very interesting. And as he said, rightly said, those who want to pursue in dark matter, they are really aspiring to be internationally acclaimed. And I really thank him for this wonderful lecture. Thank you so much.
Thank you very much, madam. He was in hurry actually. Otherwise, he could have given us more time.
So
Dr.
even I
Kulkarni.
would,
Yes, yes.
so even I would like to join to go to Arctic Circle to see the
Yeah,
wonders again. Thank
Oh,
you.
yes.
Thank you.
I think Dr. Kulkarni can take us at least to Leh Ladakh in the isolated area of observatory, where we
Yes.
can see beautiful, beautiful dark sky there, colorful with colorful nebula and other objects, masonry
Yes.
objects.
Yes, sir. Which actually that can be one of our future plans also.
Yes,
Yeah.
yes.
Yes,
Thank
we
you
can
very much.
After
Yes, sir. Dr.
After
Kulkarni, please.
seeing this particular lecture, I would like to share it with many others because there are a lot of visuals, and this is what attracts the children. They need explanation, all right. From this lecture, one thing is very clear, that the way we teach physics, chemistry, biology should not be so separated. It should be an integrated picture. When we integrate everything together, the correct picture will emerge. I mean, everybody will feel part of it. So we should be more talking about science in general, science as well as mathematics, particularly to understand subjects like astronomy, because you cannot really separate these, issues of physics and chemistry. That is one great thing I learned. Wonderful, great.
Thank you so much, sir.
Yeah.
Any other comment from members? Anybody? So thank you very much, all the members, for sparing time and joining this talk. And on behalf of all of us, I again thank Dr. KAUSTUV for presenting such a nice talk for us. And now it's time to leave. Thank you very much and good night.
Yes, sir.
Thank you.
Thank you, sir. Thank you very much.